In this presentation we're going to look at some short financial maths questions. Now this came from the Business Maths 1 paper from 2010, and it's from the maths section, and it's the first part of question 1 and the first part of question 2. So it's two short questions that were both on the paper. So first off, we have a principal of €3,500 and it is invested at 8.67% interest compounded continuously. That's an important thing. First off, continuously compounded interest. Okay. After how many years will the investment grow to €6,163? So first off, let's write out our equation for continuous compounding. So the value at time t, subscript t there, is equal to the value at time 0, the initial investment, so put a subscript 0 there, by e to the power of I times t. Okay. Now just to be clear about something, pt and p0 are t and 0 are just subscripts of p. So p0 initial value, pt value at time t, I here is interest, e is the exponential number, so it's equal to, it's the exponential number. Which is to say about 2.71 approx. And finally t, time period elapsed. So it's how long the investment has been accumulating interest. So here are all the values. P0 is 3,500. PT is 6,162. The interest rate here, we'll write it as in decimal, so it's 0.0867. The exponential number is, it's not a variable, and t is what we're interested in, so we'll put a question mark there. So anyway, we're going to use this formula here to calculate t. So let's begin. So let's just actually write it out again just here quickly. Pt equals P0 exponential of I times t. So that is equal to 6162 equals 3500 by times the exponential of 0.0867 times t. Okay, so what we're going to do here is divide both sides by 3,500, and so 6162 divided by 3,500 is equal to 1.7606, and that's equal to this value here. When we divide the whole thing by 3,500, we get this, e to the power of 0.0867 times t. Okay. Now, what do we do here? We can actually find the natural log of this and this. Now, the natural log of this here, I'll just write it in green underneath just to sort of as workings. Log to the base e of e to the power of 0.0867 t, that is equal to simply 0.0867 t. It's the definition of the logarithm of an exponential number to the power of e. By the way, just as a remark, actually, this is also, the log to the base e is also known as the natural log, so sometimes it gets written as ln. Natural log of log to the base e of 1.7606. That's a bit of calculator work, so you can actually work that out in your calculator. A bit of practice with the calculator would definitely help there. So that works out to be 0.5657, and that's equal to 0.0867t. Finally, what we're going to do here is divide both sides by 0.0867. So 0.5657, divide that by 0.0867. That will give us, that's equal to t, which we're looking for, and that actually works out to be 6.5. So the answer we are looking for is 6.5 years. Okay. Well, by the way, we know it's years because it's compound. We can sort of assume it's. We know it's years because that's actually asks us. Okay. So that is the first one there. The second question is, if 5,000 accumulates to 7,500 in 4 years, what is the annual interest rate? So this isn't a compounding. This isn't a continuous compounding question. We're just getting the effective annual rate, interest rate. So here, what we're going to do, again, we're going to set it up as follows. P0, the initial value, is 5,000. PT, the value at the end of the period, is 5,750. Sorry, 7,000. What I'm saying, 7,500. And finally, T is 4 years. But we're interested in the interest rate. So we're just going to call that I. So this is a straightforward enough one. We don't have to do any exponentials or anything like that. We're going to sort of use this formula here. PT equals P0 times 1 plus I, which is the interest rate we're looking for, to the power of t. So that's equal to 7,500 equals 5,000 by 1 plus I. I'll actually make my ones a bit clearer there, to the power of 4. First thing we can do here is divide both sides by 5,000. So 7,500 divided by 5,000, that gives us 1.5. And that is equal to 1 plus I to the power of 4. So this is where the bit of calculator work comes in. So the fourth root of 1.5, which is also equal to 1.5 to the power of 1/4. That's probably a little bit handier to work on doing a calculator. It's 1.5 to the power of 1/4, or in other words, 1.5 to the power of 0.25. Just as a quick remark, the relevant button on your calculator here for that sort of thing is this one, x to the power of y. So you type in 1.5, then you press this button, then you press in 0.25. That's how you do it on your calculator. And that is equal to, if you work that out, you would get 1.107, and that is equal to 1 plus I. So the interest rate I is equal to 0.107, or in other words, 10.7%. And that is the answer to the second one there. So that ends this presentation on financial maths, short financial maths questions.